welcome to everybody to this Digital Methods in Chinese Studies webinar. I'm Outi Luova. I'm from the Center for East Asian Studies at the University of Turku in Finland. And this webinar belongs to the training school activities of China in Europe Network, CHERN, and it's co-organized with the Finnish University Network for Asian Studies with funding from Göbel Foundation. So this webinar is also a part of the Asian Studies Days that are right now ongoing at the University of Jyväskylä in Finland. So we have a small local audience here as well, and I'm sitting here in the old style classroom. The goal of this webinar is to provide an introduction to digital methods, or strictly speaking, computational methods, and what should we pay attention to when applying those methods. And the two presentations in this webinar are aimed at China scholars who are not familiar with this method, so the presentations will deal with the really basic issues. And I hope that you have been able to read the background materials that we prepared for this seminar. A very nice paper prepared by Hui Zhao. If you haven't had access to that paper, so I will put the link to the paper to the chat box in a minute. We have two excellent speakers. The first speaker is Jun Liu. He's an associate professor in the Department of Communication at the University of Copenhagen, and his research covers political sociology, communication technologies, and computational and comparative social science. He publishes in the fields of sociology, political science, communication, and computer science. And his latest monograph that was published by the Oxford University Press in 2020 is Shifting Dynamics of Contention in Digital Age. And the second speaker is Dr. Christian Göbel, who is professor in contemporary Chinese studies at the University of Vienna. He's a political scientist and sinologist by training, and his research is concerned with the adaptability of the Chinese party state to social, economic, and political challenges. He is especially interested in the effects of digital technology on local governance in China, and he has been awarded a starting grant by the European Research Council to his research on interrelationship between popular protest, online participation, and public policy in China. And his publications include books and articles on popular protest, e-government, digitalization, and urban and rural politics in China. Before giving the floor or the screen to the speakers, some practical matters. So firstly, please keep yourself muted during the presentations. And secondly, we will collect questions after each presentation. So you can either write your questions to the chat box or then raise your hand and then say your question out loud. And the on-site audience here, so you can also write your questions to the chat box, or then preferably come here close to the microphone to say your question out loud. And thirdly, because this will be recorded, so those of you who ask questions with the video on, and if you don't want that part to be included in the recording, so please let me know so we can cut out that part from the edited version of this recording. And then also when you ask questions, so please mention your name and affiliation. So to the presentations, the first talk is titled Ask a Question That Can Be Answered, Reflections on Doing Digital Social Research. And Jun's presentation will address some issues in doing digital social research, such as the digital nature of data and data ethics. And his talk sheds light on issues and potential pitfalls we should keep in mind when doing digital social research. So welcome, Jun Liu, and the screen is yours.
Thanks, Outi. So I will share my slides. And okay, just let me know if you can see the slide.
Yeah, I can see them.
Sure. to share some of my observations on doing digital social research at the CHERN webinar on digital China research in social science, and also the Asian Study Days 2021, I think. So as Oti mentioned, that I'm doing research about the computational methods and political sociology. So I actually use digital methods like social media analytics, topic modeling, supervised and unsupervised machine learning, and also some kind of artificial neural network like a convolutional neural network, which is commonly applied to analyze visual images. And in this talk, I would like to draw your attention to some issues that I observe, experience, and think that could be, you could say, relevant when carrying out digital social research. And especially, as you can see from the title here, ask a question that can be answered. So what I would like to say is that some questions we have to seriously consider because they are impossible to answer, or you could say cannot be answered when carrying out digital social research. So by doing so, I believe it's crucial to have reflection on research design in the emerging field where social problems are addressed with data or big data and computational methods like network science, data science, computational social science, and statistics, physics. So there's another key word called digital social research. So what do I mean when I use the term digital social research? So I think that refers to the general phenomenon that technological innovation in digital communication provokes new opportunities and challenges for social research. So we could think about, for example, Web 2.0 technologies, particularly the new social media, as well as the increased accessibility of the World Wide Web through portable and prevalent devices like smartphones and tablets generate new forms of data, which are of significance for social research, as well as new methods and techniques for analyzing these kinds of data. So in other words, you could say a variety of new techniques, they are now available to analyze these large, complex data sets. And these include various forms of automatic text analysis and online field experiments and mass collaboration and many other inspired by machine learning. And then, if you look at the field, especially in sociology and political science, there are quite a lot of reflection talking about these emerging techniques and data. They can often raise more questions than provide answers. So I think there is always this question of why behind the computational data trends. So that is something I think is extremely relevant for us to bear in our mind when we choose those data, when we look at those techniques in this case. So that's why I think it's extremely relevant to think about what question we should carefully consider when adopting those digital methods or analyzing data or big data, which question could be impossible to answer or cannot be answered in this case. So let me see. Okay, so I would like to bring you back actually to a kind of pre-digital era. So that's about 85 years ago, about the story of the 1936 Literal Digest presidential poll in the United States. So I don't know how many of you know this event, but the poll was a landmark event in the history of American survey research, because actually one of the key reasons was because it predicted the wrong winner. So who was Alfred Landau, the Republican challenger, and also its forecast error was huge. So that was nearly 20 points in this case. So if you don't know much about the event, it doesn't matter. So I will briefly talk about, I think from my perspective, that's a fascinating case. So in 1936, the Republican Alfred Landau stood for election against President Franklin Roosevelt. And then we have a respected magazine, so that's a literal digest, took the responsibility of forecasting the result. And the literal digest was a very influential general interest weekly magazine and one of the most respected magazines of the time. And most important thing is that it has a history of accurately predicting the winners of the presidential election. So the magazine had run a poll on every presidential election since 1920 and had correctly forecast the winner in each. So it has a surprisingly, you could say, good track record in predicting the outcome of previous electoral contests. So that's why the poll has gained credibility among the public and politicians. So for the 1936 election, the literal digest prediction was that, as you can see in the slide here, so Landau would defeat Roosevelt. And Landau will actually win by a convincing, I think it's 55% to 41%. But we all know that actually the election delivered a very different result because Roosevelt actually crushed Landau by 61% to 37%. So that event, unfortunately, I would say that destroyed the credibility of the magazine, Literal Digest, who went out of business 2 years later. But actually, if you look at the detail, I think Literal Digest, they conducted a poster opinion poll, you could say, of astonishing ambition, as you can see here. So its aim was to reach 10 million people. So that's a quarter of the electorals. So actually, the Literal Digest poll was also one of the largest and most expensive poll ever conducted. And then they also collect the sample size of around 2.4 million people. That's a huge number if you think about the survey research. So that's a huge number. So what went wrong in this case? That's something very interesting. They have such a huge project and collect quite high kind of response rate of these poll. So one of the key problems with the poll was in the selection process for the names on the mailing list. So those names were taken from telephone directories. So telephone books and list of automobile owners, club membership list of magazine subscribers, so on and so forth. So that is the problem. Why that's the problem? Which we must remember that in 1936, so telephone, let alone mobile phone, were much more of a luxury than they are today. And also at the time where there's still, you could say, 9 million people unemployed. So the name of a significant segment of the population would not show up on, for example, list of club member and magazine subscriber or list of automobile users in this case. So the list that the Literal Digest select, that list was guaranteed to orient towards middle and upper class voters. And by default, you could say to exclude lower income voters. So at least with regard to socioeconomic status, you could say the Literal Digest mailing list was far from being a representation of the population. So that is one of the major problems. So that major problem, if you look at statistic book, that refers to a very dangerous kind of pitfall when we think about doing social science research. That's what we call the sampling bias. So what is sampling bias? Sampling bias is when the sample is not randomly chosen at all. So more specifically, you could say sampling bias happens when the data sample in a systematic investigation does not accurately represent what is obtainable in the research environment. So when we as a researcher, when we gather data in a way that some member of the intended population have a lower or higher sampling probability than others. So that result is sampling bias. And that is very dangerous when we carry out kind of social science research, because sampling bias is it's also a crucial pitfall, because many times it happens unintentionally, as we can see in the case of the 1936 Literary Digest poll. So that's without the knowledge of the researchers in this case. So the prestigious journal actually did not realize this issue. So many times our research design and our research methodology can impose sampling bias on our data gathering process and thereby change research outcome. So that is one of the relevant experience from the 1936 Literary Digest poll. And there's actually another very interesting anecdote along the side. I think also during that presidential election, George Gallup took, George Gallup used a very, you could say much small data. So he only used 50,000 actually kind of from the opinion poll and predict the correct result in this case. So I think that is something extremely interesting for us to think about in this case. So why I think 50,000 samples were able to predict the correct result when we have 2.4 million actually kind of sampling, then I think we get the wrong answer in this case. So I think that is something, especially when we think about kind of digital social research. So when we think about digital social research, so one of the common kind of assumption here is that we no longer have to sample. So we have the entire background population. So that's the question of n equals or. So when n equals or, there's indeed no issue of sampling bias because the sample includes everyone. But I would rather put a question mark in this case to ask, is n equals or really a good description of most data sets that we are considering with, for example, computational social science tools? So there's a lot of criticism, there's a lot of reflection challenges the notion that one could ever have all the data. One of the example is Twitter data. So I think it's, in principle, you could say, possible to recruit and analyze every message on Twitter and use it to draw conclusion about public modes. I think both researchers, they use a subset of what's called a Twitter fire hose in this case. But why we look at, we can look at all those tweets, of course, but then the Twitter users, they are not representative of the population at all. So that is the problem of sampling bias. So if you look at the Pew Research, Internet Research Project, for example, then you can see the US-based Twitter users were disproportionately young, urban, and suburban and Black. So it's not a representation of the population, of US population as a whole. So that is the problem. So that's why I think there must always be a question about who and what is missing in this case. I think that is very, very relevant for us as a researchers to think about which question actually cannot be answered when we use, for example, data from the social media side, social networking side. I read a lot of studies to use, for example, Weibo data to study in the case of China's social media spheres to talk about online public opinion. So I always have a kind of question mark as a kind of a critical mind here, say actually what kind of public opinion you are talking about? Well, what kind of online public opinion you are talking about? So what kind of question you could answer with such kind of Weibo data? So I think that is something we as the social scientists, especially when we carry on research about China-related digital method-related kind of research, then we have to bear that in our mind. So I have another example that I have been carried out. So I have done some research about content moderation on Chinese social media. In some cases, people talk about censorship online. So there's some kind of prestigious, largely, and you could say very influential studies about the censorship on the Chinese social media. As you can see here, I'm quoting some methodological descriptions from their studies. For example, Batman and his colleagues talk about extracting terms from the messages, and Kim and his colleagues talk about computer-assisted text analytic methods. King Wafu from University of Hong Kong used this discriminatory keyword analysis, and there's also some study talking about text analysis of the post from the Weibo in our data. And similar to those censorship studies, when we look at anti-censorship studies to look at how Chinese online users or Weibo users circumvent the censorship, then we can also see, for example, some of them talking about their study object is about satire in the Chinese cyberspace. They look at these ironic, parodics, and hybrid satires. And there's also some study to talk about this satirical text using content analysis. So when I look at those studies, so what is in common when you look at their methodological justification or methodological description? So one of the things that I criticize or I put a reflection on the methodological issue is that I address that, yes, they study the censorship or anti-censorship practices on the Chinese social media, but apparently they have a very, very strong focus on the textual content on the Chinese social media. And if you look at the method, even in some cases, you could argue that they have an exclusive focus on the textual content on the Chinese social media. But if we think about what happened online, when you surf the internet, we know that actually apart from the textual content, we also circulate multimodal content. We send out images, videos, URL links, or in some cases, actually, we combine textual with other multimodal content. So the textual part is irrelevant, but only part of people's online communicative activities. So that is something I'm traumatized when people carry out such kind of censorship studies. So actually, in this case, what I was arguing in one of my articles is that actually we can observe a kind of sampling bias in study either censorship online or anti-censorship practices online, because they present an incomplete picture of censorship mechanism. They only focus on those plain texts without notification of the diversity of people's online practices that involves non-textual modes. Memes is apparently one of the key things that people actually, especially on the Chinese social media, but also on Twitter, actually people use to express, to engage other people in political participation. And if you look at these studies that actually adopt those textual-based kind of analytical tools or research design, they also acknowledge that apart from the deletion of textual messaging, there's also the censoring of those containing subversive images and videos at all. But when they actually carry out those research with textual-based computational methods, so apparently they ignored those multimedia part. So that is, you could say, a sampling bias, going back to my earlier discussion when I used the example of the literacy digest poll. So the sample, the population that exam failed to represent the whole population on the Chinese social media or on Weibo in some cases. So that's why, for example, we know that the image has been banned on the Chinese social media. But then when those studies consider the censorship online, so they forgot that part. So that comes to one of my studies together with a collaborator, which has been published this year. So in that study, actually, we studied not just the textual part of the online content, but also the multimedia part. And I will just give those methodological discussion, and we study the umbrella movement in Hong Kong, and then the Weibo discussion on the umbrella movement in Hong Kong. So I think I just go directly to our conclusion. So one of the major arguments that we advance in this study is that you could say, theoretically speaking, the censorship deletion rate on the Chinese social media, Weibo in this case, should be higher than the major existing studies focusing on plain text that have reported. Because current study, as I said, on online censorship in China has presented theories of, you could say, textual-based content removal and fabrication strategies by the regime. So despite their significant kind of results, this study regrettably underestimate the deletion rate because Chinese internet users produce a substantial amount of multimedia posts. And in reality, censorship blacks out both plain text and multimedia content. So that's why the censorship deletion rate should take into consideration ignore the censored multimedia posts. So that's why I think one of our suggestions is that future efforts should either clearly acknowledge their specific preference towards certain modes in their theoretical assumption or methodological design. For example, I'm only focused on the textual part, or I'm only focused on the multimedia part, or deliberately take real-world settings. So that's multimedia-rich online practices into account in order to get a comprehensive picture of the complexity of censorship or anti-censorship mechanisms. So that's one of our main kind of argument. And the second thing, actually, when we study this multimedia censorship, then we figure out that censorship has a strong preference for multimedia posts over plain text on account of the former's popularity and influence. So that is also another very interesting observation. And the third thing, actually, we have a broader implication, both theoretically and methodologically, to social media analytics. So that is actually, we actually would like to kind of remind scholars to be cautious about these sampling bias in the text-based analytics of data collection, selection, and analysis. So that's why we actually suggest a hybrid analysis of media is needed in the social media analytics, even though we have very advanced techniques to carry out textual analysis. But we still need to consider what happened in reality. So I think this is one of the kind of key issues you could consider when you use those big data techniques, when you carry out research with data from, for example, social media on Chinese, either Chinese kind of case or beyond the case of China. I think that has a broader theoretical implication in this case. And lastly, I'm briefly talk about another kind of issues related to data ethics and challenges that is also based on my experience. So we actually received one of the kind of review from one of our recent publications. So we are very lucky because the publication has been accepted. But as you can see here, I'm quoting the request from one of the reviewers. And because we are doing research about the Chinese social media, and we did this translation from the Chinese content to English. So there's a request from the reviewer say that there's a matter of getting lost in translation. So that's why it will be a good idea, actually. So the reviewer suggests that we should provide the original Chinese wording for the full posters for clarity. So that is, to a certain degree, understandable, right? But at the same time, especially for us, I think the scholars within the European Union, then we should also think about the GDPR, the data protection laws in this case. And I realized that actually the situation varies across different European countries. So I can only speak about my case in our situation. So that's the University of Copenhagen. And in the case of University of Copenhagen, the university requests that we should be very, very careful to deal with personally identifiable data in this case. So if your project, as you can see the description here, contains a nominal data, then you do not need to register an approval from the university. But then if you use the data that is possible to identify person in question in any reasonable way, then you have to think about GDPR and data protection. And in this case, so it's reasonable to think about if you provide the original Chinese wording of the post, then it's quite easy for people to simply search that post on the Weibo search engine. And then it won't be difficult to identify who are the posters, who are the Weibo users in this case. So that's why actually we are very lucky in this case, because we actually argue against the reviewers in this case. So we did not offer the original Chinese wording. And then our article gets kind of accepted. But this case also kind of reminds me about another very, very interesting case in internet research, because that's my research field. So that is a research project called Taste, Ties, and Time, which is a longitudinal study conducted by a group of researchers at Harvard University and the University of California, Los Angeles. So the team was investigating the nature and dynamic of social networks using Facebook data from an entire cohort of undergraduate students at the universities in the Northeast United States. That's so more detail is that beginning in 2006, each year a team of professors and research assistants, they scrapped the Facebook profile of all members of a class of 2009 at a diverse private college in the Northeast United States. So the longitudinal data from Facebook on basically on friendship and culture taste was merged with data the colleagues had about the students' residential dorms and academic majors in this case. So that is what they did. And then I think in addition to use data for their own work, the Taste, Ties, and Time research team, they also make the data available to other researchers. Of course, after taking some steps to protect the students' privacy in line with the wishes of, they got the grant from National Science Foundation because I think they request the open data. And I should also say that actually all procedures were reviewed and approved by Harvard's IRB and Facebook. So they follow every and each step in this case. So that's actually the researcher did not actually identify the institution, remove students' names and identification numbers from the data set, delayed releasing the cultural interest of subjects. So for example, movies, books, TV shows, and music. But unfortunately, just days after the data were made available, other researchers deducted that the school in question was, they can identify the college. So within a day, a researcher actually from University of Wisconsin, Milwaukee, was able to determine that the data came from Harvard. And actually, the researcher did so without accessing the full data set. Although I think the researcher did not identify individual students, it was clear that the data set includes enough unique indirect identifiers to re-identify the students. So that was a kind of major issue. So that's why there's a lot of accusation, as you can see here, to talking about actually the project failed to adhere to ethical research standards. And there was also a kind of report talking about Harvard researchers accused of breaching students' privacy in this case. So I actually use this case at the end of my talk because that's kind of a common issue I would like, rather than providing an answer, to kind of try to initiate such kind of discussion about the data accuracy, especially when we are doing research about China, when we need to, for example, do a kind of translation. There's a question about translation. There's a question about the open science requirement, open knowledge requirement. So I think that is something worth to consider in this case. And thank you very much. And I look forward to the conversation with you.
And many thanks, Julie, for the excellent presentation. Now it's time for questions. So please, if you have questions, you can write them in the chat field, or then raise your hand and say out loud your question. While waiting for the questions, so I would like to ask you two things. One is about the complexity of the social media field in China. Because what I have understood, there is a lot of bots sending both pro-government messages and also messages critical to government, and how to identify these bot sent messages in this vast sea of all the posts and communication. And then the other is, you mentioned the GDPR and how it affects our life as researchers, but then there is this new personal information protection law in China, and I wonder if you have any idea of how it might affect our work as China researchers. Thank you.
Yeah. Thanks very much. I think the second question, I would probably talk about that first, because I think this is something that pending on a kind of further elaboration, but also collaboration and reflection between the European and Chinese scholars. This, I think, the Chinese data protection law, then to what extent actually it will influence the data collection and analysis within the European country. But I think my general understanding, of course, that's something that we could open floor for the discussion, but my general kind of understanding was that actually the GDPR is very strict in this case to think about personal data collection and analysis. In this case, actually the Chinese kind of personal data protection law is more or less in line with the requirement in the GDPR, because it gets a lot of inspiration and kind of lectures from the GDPR when people are drafting this kind of content. So in this case, actually, there's a lot of similarity, you could say, between the GDPR and the Chinese data protection law, I think, on this policy level. But I think, again, I think the difficulties could be that on individual level, for example, individual countries or individual institutions, now actually we have different specification about data protection. So this is something that is, I think that is depending on individual researchers to maneuver and to explore. For example, you can see that's also one of the reasons that I use the policy requirement in the University of Copenhagen, because I can only speak about my institution. And I realized actually, even within the university in Denmark, we have very different requirement about data protection, about what kind of data you could use to do a kind of research. So I think this is something that definitely worth to think about. And I think also you raised a very, very relevant question, because I think there's definitely chance to think about how actually if the personal protection law in China will affect the access to the Chinese social media data in this case. And then I think speaking about the bots in this case, actually there are different, as far as I understand, so there are different actually mechanisms, there are different tools that you could use to detect bots. So for example, I know that there's called botometers, which you can use in the case of Twitter data. And there's also other similar tools that you can adopt to carry out research to identify the probability of a social media account to be a social bot on the Chinese social media. So that's definitely a lot of kind of tools available to detect the bot on different social media platforms. Actually, I'm involving into one of the research projects to study social bots during the kind of in the discussion on the vaccine issues on social media. So that's why I think we're actually dealing with that kind of social bot detection at this moment. So, but there are a lot of actually tools available to help people to identify the probability. Of course, you won't be able to say that this is bot, that's not bot, but you have a higher percentage of probability, say that maybe 80% or 90%, this is the bot account in this case. Yeah.
Yeah, many thanks. And then we have a question from Lena Kaufman. Please unmute yourself.
Yes, thank you for a very interesting talk. Actually, the second one I've heard of you already on a similar topic, and I have two questions. So one is about the bias about texts, and then also about videos and pictures that you mentioned. And maybe you mentioned this, but I missed it. But are there, for example, any algorithms with which one could also investigate video material? So this is one question, practical one. And another one is maybe a little bit more personal, but also general, because I mean, this type of topic that you're researching is also quite sensitive, I imagine, and the Chinese government doesn't probably want people to do research on this. And so I'm wondering if you, when going to China, face any problems in conducting research or in visiting there, because for me as an anthropologist, where I have to, I mean, I need to go to China and yeah, to conduct field research there also. I mean, it's always a challenge, obviously, to balance this. Thank you.
Yes, thanks. I think the first question about algorithm related to the multimedia content. Yes, we definitely believe that there should be some kind of algorithm targeting specifically about the multimedia content, especially about the image. So that is also one of the reasons that we actually, I think this is ongoing research. We use the what I mentioned is convolutional neural network, which is a kind of machine learning, deep machine learning specifically applied to the image to study if there is an algorithm tailored to image content on the social media, and if there's a kind of preference about either the textual-based algorithm or the image-based algorithm when governing the online content. So this is definitely something that we consider. But I think, of course, one of the difficulty you could say is that we don't get access to the company, the algorithm. So that's the kind of, as you say, that's kind of black box in this case. And the other thing that we should consider is that I think a lot of study already identified that censorship actually has been carried out by the manpower kind of manually. So that's why I think it's not, I don't think it only depends on the algorithm. So that is also some kind of knowledge that we can learn from existing studies. So that's why I think this is something intriguing question, but also very complex question that we have to bear in our mind. So this is something that we should think about. And the second thing about the sensibility of the topic, I think actually my experience is that actually there are a lot of similar projects carrying out by the Chinese scholars in the Chinese mainland, because I think online public opinion is one of the crucial part of internet governance in this case. So that's why I think actually we're just talking about different approaches, because I also have several collaborations with Chinese colleagues. I'm doing this kind of research in this case, but I'm not an anthropologist in this case. And I have to say that I talked to a question earlier before the semester, the seminar, that actually I haven't been on the field for, I think, almost 3 years. So that's definitely a disadvantage thinking about that you don't get this data on the ground in this case. When we say on the ground, you're talking about the offline kind of situation. So that's definitely some kind of disadvantages we should think about. That's also one of the challenges, I would say, for people nowadays to carry out the research field work in China, I would say. But I think it depends, again, going back to this, it really depends on what kind of research question that you would like to ask. I think in this case, for example, because my research mostly about how people appropriate and justify the use of specific technologies for politics. So I'm less focused on, for example, the motivation or intention, but rather focused on the use of technologies and media repertoires in their everyday life. So that is my specific topic in this case.
Okay, thanks, Jin. I think we have to move on, and if you have any further questions for Jin Liu, so you can ask them at the end of this session. And now let's give the floor to Christian Göbel. The title of his presentation is Researching Social Unrest in China, a Data Science Toolkit, and his talk introduces some tools that can be used to study China in the field of social sciences. So please, Christian Göbel, the floor is yours.
All right, now I've unmuted myself and I think you can see my screen, hopefully. So, all right, good. Yeah, thanks again for the invitation and good morning, everyone. So this presentation is, well, a little bit more hands-on. So I took it from the invitation that the audience here is, well, not trained in digital methods, and so that I would be able to give a talk that is really addressed to beginners. And what I would like to do is to just show you a little bit. I've been working on protests and studying protests in China for several years, and to just give you a little insight into how I've been doing this work. Now, just a second, yes, this is one of the main sources for my research on protests in China. It's a collection of more than 70,000 protest events collected by, well, activists now, you might say, Louis Yu and others. And yeah, so in order to study protests, of course, I wanted to have the material that is on this webpage. It's a blog, you see the URL, so you can access it as well. And to have it on my computer, so to be able to work with it. Now, let's say that we want to download the entire content of this webpage that you're seeing here onto your computer. Now imagine or think about, or maybe if you have the time, write it in the chat, how many lines of Python code would that take? I'm asking this question also to, well, maybe get you motivated to try these things out yourself. It's fascinating work to do. It's fun, and you get to know a lot about the data you're doing. I mean, something that I think you gathered from the last talk from my predecessor is that even if you do work with digital data, and if you do work with, I don't know, big data and sources that contain a lot of information, you still need to know these sources very well, and you still need to know what is in them, and if the models you are calculating make sense or not. And to do that, you really need to immerse yourself in the material. Well, the answer really is, if you only wanted that web page, it's actually one line of code or 2 lines of code. So you import a library that is specifically designed to download content from the internet, and then you open this link and you read it and you print it out on your screen. But what are we going to do with the copy of a web page? Now, of course, I want to extract and store specific information, such as links to individual posts and the content of these posts, and the date and the locality where a protest took place, and the location and other information. So in the next example here, I'm showing you a slightly longer program that will now parse or download all the links in a specific format from that page that I've just shown you. So it's also not a very long snippet of code. You see that I've imported a second library called Beautiful Soup that you can use to sort of grasp or take specific information from the HTML code. And doing that, well, you get like, I don't know, 20, 30 links. If you remember the first page, you'll see that you had links directly to reports on protests, but you also on the right-hand side had links to other links. So one link per day, and then for each day, you have a lot of posts. So of course, what we would now like to do is to not only download the links on that one page, but also the links to the links, and maybe then even the links to the links to the links. So in order to do that, we just create a function. You basically see that this function where you have the def before it, and what is under that is just the same content that I had in the last program. And then I start this, function basically is a machine where you put something in this case, a link, and you get something out, a list of links. And what I did here is I, put in all the links I get from the first page, I put in the link from the first page, get out all the links that are on the first page, and put these links in again to get the links that are on the second level. And what I do then is, because there is no use in just printing out these links, I use a third library, which I recommend to you if you want to do this kind of work, called Pandas. So it's also a data manipulation library. So I saved that. And just to give you an idea what happens when you do that, I've ran this program here at home. And this is about the speed if you have one worker where you are the amount of links that you're capturing. So within several minutes, within several seconds, you already have more than 1,000 links. And if you continue doing that, you can easily download all the links of that web page within a few hours or so. Now, of course, what do you do if you have several million links? Well, you can add some lines to this already very short program. So, it was just a few lines to download so many links. But if you want to scale that, if you have websites that have a few million links, of course, it will take forever. So you could now write another function where you use all the cores in your computer to download more data to, for example, have 4 or 5 programs running at the same time. This is called multiprocessing, but this is something where an ethical aspect also comes in, because theoretically, you could go and use a high performance cluster, use several hundred cores to download data from website. And of course, if you do that, your URL will be blocked and you will not be able to get any more data, but you could use proxy servers to do that. But, if you try that and if you're doing that, you're committing a felony. So if you do, and if you have a lot of cores, you can easily do hundreds of requests per second. That is a DDoS attack, a distributed denial of service attack, which at least in Germany can get you prison for 3 years. It's also not very nice for the other website, because if you're accessing the website, if you're using a heavy duty scraper, you're taking away bandwidth from that website, meaning that others cannot access it anymore. So the ethics of web scraping dictate that you should scrape responsibly, meaning that you look at the website, and if it has a small bandwidth only, then you only download little data at a time. But there are other issues as well. So, for example, if you want to download content from more web pages, if you want to parallel scrapers, you'll see that sometimes the servers yield no response, and then the program crashes, but you don't want it to crash, you want it to try again. So you need more code, or you want to save the images to disk, to analyze them, to use, I don't know, convolutional neural networks named by Liu Jun in the talk before, more code and so on. So these 2 lines of code from the very beginning can easily turn into thousands of lines of codes, which is fascinating and frustrating at the same time. Fortunately, very often you don't have to do this work. So for web scraping, you have an application called Scrapy that is very versatile. It takes some time to get into it, but you can configure a lot of options that do exactly what you want it to do. You can also work on the source code, manipulate it in a way that you can just get the results that you want to get. And when I say there is an application for scraping, this is of course also true for other domains. So for everything usually that you want to have help in the form of an algorithm, it usually already is an application. And and if you do a little Googling and searching, you'll probably find it, so you don't have to reinvent the wheel. Okay, so now I've got this data from I've written the scraper. I know how to get the data from the website. Now I need to store it, and just very, very quickly, I don't want to get into this slide in detail because it's very technical. The message that you should take away from this slide is don't use Excel or CSV files or so on to store data from websites, because first of all, it's not scalable. The files become very quick, very large, very quickly, and they are then liable to corruption. Also, if you store text in comma-separated values files, it's also likely to get corrupted, because you might have a comma in the text, which is also used to separate these values. And even if you use other symbols to separate your columns, the larger your text is, the more likely it is that the symbol is also in the text, and then your data is gone. So use databases. There are 2 different kinds of data storage, or main kinds of ways of storing data. One is relational databases, so it's basically tables and columns. But there is another one that is used when you access the Twitter API, for example, the Weibo API. So data of social media is usually stored in a dictionary format called JSON, which is more versatile. And so I've written down a few database programs that you can use to store data like that. Also, if you collect a lot of data, it is advisable to have a database server. So not only just a program on your computer, but actually a server that can also distribute accesses if you're downloading a lot of data. So what I've done then is I've looked at I've got the content that you see in the bottom right-hand corner in my computer, and told the scraper basically what information I want to have stored where. So for example, here you see that there's a date, so I taught it to recognize the date and the localities, the headline, the content, and all stored it into
can't hear
specific.
anything.
Sorry? What's that? Can you still hear me?
Yes,
Hello?
we can hear you.
We can hear you.
Yeah.
Okay, because
Yeah.
that was, yeah. And you can still see the screen, right?
Yes.
Okay. Okay, then, so let me see. Now I need to get my screen back. Okay, no worries. All right, so, okay, so having stored the data, and what you see on the right-hand side, or well, on this image on the left-hand side, no, in this on the left-hand side of the image on the right-hand side, it says Gongren. So the creators of Wikidonna also gave us a keywords. So they specified keywords, and they did a very good job in doing that. So you know, these keywords can also be then used for classification. So they will definitely come in handy. Now, the next step after that is segmenting it, because as you can see here, the text, you know, it's Chinese text, there are no white spaces in between. So character follows character. Even if 2 characters or 3 characters form a word, there is no white space between the characters. So what you need to do when you want to work with natural language processing tools written for languages that have white spaces, most or all Western languages, then now it's small. Okay, just a second. I'm sorry. And okay, we're back. Yeah. Sorry for that. So what you need to do if you want to use applications for natural language processing written for languages with white spaces, that you need to artificially impose white spaces into the Chinese texts. And there's a library called jieba that does that for you. So what you see here is that I've taken the messages that are on this website. I've separated them, and not only separated them, but used a part of speech tagger to indicate if each word is a noun or an adjective or an adverb, and so on. This has the added benefit that when you do processing later, you can, for example, exclude numerals, or you can exclude measurement words and so on, or you can only look at verbs or nouns or whatever. So, and what you also can do is sort of little games like making a word cloud from nouns in the corpus. These are things that often look great in presentations. I'm not sure if they're so useful for research, but they also give you a first indication of the words that are frequent in the corpus. Now, but I really want to know what kind of content there is on this website, and word clouds are not enough. And for this, you can use topic models that have already been mentioned. They've become very fashionable in political science, maybe a little bit too fashionable. They're often used for classifying text or classifying content. And for reasons I'm happy to answer in the Q&A, I think this is not always a very good idea. And I'm more a fan of supervised learning, which means so that I train a machine learning algorithm based on the data and not just have it figure out meaning by itself. But again, here, you know, I use the LDA topic model for one with a Jensen library. So it looks like that. You just tell it to take the whole corpus and then, you know, find words that are related to each other. And it does that, and it runs, and it calculated it, and it's very nice to look at it, how then sort of meaning is being created, how topics emerge, and how the topics then hopefully make sense. Now, here, I've just stopped it. So you see, here's topic 0, if the screen is big enough. So you have words like 政府老百姓是政府人民商房. So obviously this connection makes sense. So this topic obviously is about, you know, protecting your rights and petitioning and so on, or protesting. I've translated these into English, and here, you know, you see not only topics on the act of protesting itself, but you already see the first sort of issues that people are protesting against, like land grabs or real estate issues or medical issues, evictions, and so on. So topic models help you to get sort of an idea of what is in the corpus. Now, this is LDA, which again, as I said, is often used, latent Dirichlet allocation. Very recently, there's been HSBM topic models, which I like a lot because they're, well, not based on a prior distribution that is being assessed and that sort of has to be then changed. Well, I'm not going to get into that, but this is HSBM topic models is a program or a kind of topic modeling where actually connections between words in the text are being used. So it's community detection through networks, and then you use these networks to sort of detect hierarchies of topics. The nice thing about this is when you do LDA, you need to pre-specify the topics. So you need to say, well, you know, I want to extract 10 or 15 or 20 topics or 100 topics. And it's usually very difficult to say how many topics you really need or to adequately reflect your text. It's a lot of trial and error. It's a little bit of, you know, alchemy and witchcraft to find the right number of topics and to put in the right number of stop words. And with this technology, you don't need to do all of this. You don't need to cut out stop words, and the number of topics is extracted by the program itself. So it has a lot of advantages over LDA. The only disadvantage, I would say, is that it's computationally very, very intensive. So if you have a corpus with, I don't know, 1 million documents, it really, really struggles. You need a lot of RAM power. Now, no matter which topic model I use, once I have the topics, I can, of course, assign the topics to different posts or entries I have. And as you've seen, I also extracted the dates from these posts. So, you know, I can then, for example, this is not now from the protests, but Weibo posts on the term teacher. I can then, for example, visualize how a topic that is related to democracy and democratization has increased in the first years of Weibo and then has slowly decreased after 2013, which perhaps not incidentally is the year that Xi Jinping came to power. What GenSim, the model I used to do the LDA modeling before, also does is it allows you to calculate word embeddings. So you can train a shallow artificial neural network to basically learn which terms in a text are sort of related to each other, near to each other. And you project sort of all these words and combinations into hyperspace, and then calculate cosine distances between the words. So what you can do, which I think is very useful, is you can use that to find synonyms. So here I used the term weiquan, and then you see here 25 terms that are related to or close to weiquan. And it also indicates how close they are to each other. Or you take words related to social unrest and calculate the distance to one very radical word and one very sort of soft word of trying to defend your rights and calculate the distance. And then, as I did here, put the frequency, how often the terms appear in the corpus, into the y-axis, and then, you know, for example, try and get an idea if there are more radical posts or fewer radical posts in the data set that I've collected. And of course, visualize it. Now, I said I'm more in favor of supervised text classification, and the labels that the creators of Wikidonna supplied with their talk, with their entries, come in handy. So you can use them to have, you know, the text, the post that is on the website and the label. And once you have a text and a label, you can train an algorithm to, well, learn and distinguish between posts that are related to protest and posts that are not related to protest. One tool that is also in the article that you've been given is support vector machines, which I like a lot. There's a library in Python called scikit-learn, a machine learning library. And support vector machines are easy, they're fast, and they're good value for money because the accuracy is really decent. Recently, long short-term memory or convolutional neural networks, so AI, you know, artificial neural networks have also been used for text classification. I wrote about these, what's the point really? Because we have in the third row transformers like BERT from Google or Ernie from Baidu that are trained on billions of documents, and that you can fine tune to, well, also extract the information that you like. And because they, in a sense, already speak the language, and you just tell it to recognize, you know, what might be related to a protest and what might not be related to a protest, they're doing a very good job. So I think if it has to be fast and easy, use support vector machines. If you have a GPU, use BERT or Baidu. So for me, I don't really see the point of using artificial neural networks for text classification. Now, once you've done that, of course, again, if you extracted the issues, if you used transformers to, well, not only recognize if a post is about a protest or not, but also what kind of protest, what type of issue it is. You can also visualize it. You use matplotlib to, for example, visualize the development of protest issues over time. So here you see very nicely how labor, or the prevalence of labor issues in the corpus, increases and decreases. So whenever you have a Chinese New Year, or just shortly before Chinese New Year, you have more labor issues, and then afterwards they're decreasing again. What you can also do is using the images. You know, for example, if you want to know how big are the protests, you can use YOLO, you only look once, where you can count persons in an image. And then, you know, here, and then try and see if big protests have increased or decreased across China. But of course, you can also classify unseen images using the CNNs that we've already talked about. So I can use the Wikidonna images and a random sample of images not related to protest, train a CNN to sort of spot protest images, and then maybe download images from Weibo and have the algorithm predict if it's a protest or not. Then also nice, and this is not a Python library, but it's a standalone program with a graphical interface. QGIS, you can create a CSV of your data. You can get yourself some shape files for China and Chinese provinces, cities, and counties, and then use that to create a map of China and visualize protest densities. QGIS is also, like everything else here I've introduced, open source. Now, coming towards the end, just very quickly, if you want to do these things, what are the coding skills you need? And the good message is, you know, first, I mean, you need to install libraries and dependencies with programs like pip, apt-get, and so on. It's not very difficult. It's easy to learn. Most libraries come with sample code for demonstration. So here, for example, you see this program for creating information on images. So you put that into your terminal, press enter, and you get an image like the one below. So really easy. But of course, I don't want to just classify one image, but maybe 500,000 images. And I don't want the information of the image printed on the image itself. I want it in a file so I can write it in the database to provide more information on the information that I already have. And this means that I need to change the code to serve my needs. And again, this is sounds more difficult than it is. And just a little example. So here with this program that sort of runs and classifies one image as a demonstration, you go and first, in the right-hand corner, create a function to assemble a list of images I want to process. So that's the first thing. So instead of feeding it one image, I'm feeding it 500,000 images. But as I said, I want the information on how many persons there are, and I don't want to print it on the image itself. So I go through that program and try and find the variable where the information is stored before they print it on the image. And I found it. It's called bbox results. It's a dictionary where all the items are stored. Then I write a very little line of code where I said only extract information on persons and count the persons. So, and use that information to store it in the database. And because processing 500,000 images at the same time is computationally very expensive, I used the last line to batch process it. So I sliced it into batches of 1,000 and go 1,000, 1,000, 1,000 until I have 500,000 images. So basically what you need is, the skills to install libraries, also to query databases, to import modules, load data, selecting, iterating over data, altering, repairing functions. It's something that takes time to learn, but the good news is you can start with small projects and then extend it, Google errors and problems you might have, and in that way improve your coding skills. Yeah, just some favorite libraries for data manipulation. Pandas, I mentioned. For network analysis, we have GraphTool or NetworkX. Visualizing data with Matplotlib, Seaborn Plotly. Statistical analysis, stats models is very good in Python. Scikit-learn is good for machine learning without a GPU. With a GPU, natural language processing, you can use GenSim or Paddle. Ernie, I already mentioned. Image classification, YOLO, also from Baidu, and TensorFlow, and then artificial neural networks, of course, Keras and TensorFlow. Tips and tricks, just acquire some basic programming skills. There's, for example, Zed Shaw's book, Learning Python 3 the Hard Way, a very simple introduction to the terrifying, beautiful world of computers and code to get some ideas of how the language is structured. Start with small projects, experiment with the codes of others, and search for libraries that might deliver what you need instead of trying to do everything by yourself. And of course, for errors and code snippets, use the internet, use Stack Overflow. So a lot of programming really is copy pasting others' data, modifying a little bit, and then running the program. So it's not that everybody just sits in a dark basement and writes the code from scratch. It really is a lot of copy pasting. Thank you.
Many thanks, Christian, for the excellent presentation, and you made it look so easy and simple. And yeah, do we have questions from the audience? Written questions, or if somebody wants to speak, say out loud the questions. Not yet. First, I would like to remind you that this is recorded, and you will have this recording available later, so you can go through the talk and the presentations, and maybe we can also share the slides later on, so they will be available.